Toxic metal effect on filamentous fungi isolated from the contaminated soil of Multan and Gujranwala. Considering the importance of filamentous fungi for bioremediation of wastewater and contaminated soils, this study was planned to investigate the metal tolerance potential of indigenous filamentous fungi. Certain metals are important to biological actions. However, all metals, whether essential or inessential, will show toxicity at certain levels. During 2012, total 17 fungi were isolated and preserved from contaminated peri-urban agricultural areas of Multan and Gujranwala for further detailed investigation of heavy metal tolerance. Aspergillus niger, Aspergillus fumigatus and Aspergillus flavus isolated from both soil and water samples, while Aspergillus terres and Penicillium sp were only isolated from soil samples of Multan, and Aspergillus versicolor, Aspergillus flavus, Fusarium oxysporum, Aspergillus niger, which were isolated from contaminated soils and water samples, while Penicillium sp was isolated from only water samples of Gujranwala. These few fungal isolates were selected for tolerance to metal Cu, SO42.5H2O, CD, NO32, Cr, NO32 and PD, NO32. The tolerance strains were selected with increasing metals concentration of 100 parts per million and compared to control in the medium. The degree of tolerance was measured by radial growth, cm, in the presence of various heavy metals and compared to the control, which contain no heavy metals. The present study investigation concludes isolates Penicillium sp and Aspergillus flavus isolated from soil of Gujranwala show maximum tolerance index 2.1 at 100 parts per million toward Cr and 4.8 at 100 parts per million toward Cd respectively. Aspergillus versicolor, isolated from wastewater, exhibit considerable highest tolerance index toward Cu and Pb while show a sensitivity against other metals. From all the collected samples, the Gujranwala soil and water show more tolerance toward the heavy metals as compared to Multan area. The present study indicates that in future similar strains will be tested with other heavy metals for the confirmation of tolerance, and tolerant strains will be used for bioremediation of heavy metal.